Hello, my name is Williams, and I'm doing this presentation for California International University for my class GRC 605. For this week, we're talking about the chi-square test of independence. And for this presentation, we're going to go over three samples based on the database that we used last week, in which we were looking at correlations between two variables. Introduction here is what we're doing now. I'm going to follow up by the chi-square test, and there's three in total. All three of them look at different nominal variables. And then we're going to go do important takeaways, in which we discuss the results that we see, as well as the general idea of how the chi-square test and the Cramer's test works. And then we follow up at the conclusion, which we do our things and give you a chance to have questions. All right, so first thing, let's look at the Cramer's V interpretations here. One thing about the Cramer's test is that it's pretty straightforward with the results. The numbers for the result varies from 0 to 1. And 0 means there's no relationship at all, while 1 means there's perfect geometric relationship. But do note that by the time it gets to 30% or 0.30, it's already a very strong relationship to the point where if it gets much higher, it's a question whether it's redundant or so. So that's something to note when we're looking at Cramer's V interpretations. Also to note that you only really do Cramer's if there is a relationship to talk about. I do have on my screen the Cramer's, even if there's not a relationship between them, just for the sake of doing it. But at the same time, it doesn't really matter much if there's no relationship. Our first hypothesis here, which is the number of cars to number of defaults. The null hypothesis, which there is no relationship, is there's no relationship between the number of cars and the number of defaults. The alternative hypothesis is there is a relationship between the number of cars and number of defaults. When it comes to the chi-square test, you can also say this is also looking at independence here. If the null hypothesis is retained, that means the two variables are actually independent from one another, in which they don't depend on the ratios varies from one another. While alternative one, that's when there is a correlation between it. So it's similar to what we did last week. In this case, with the results, you see that the 6 there, that's for the degrees of freedom, in which it kind of tells you like what ways a person can manipulate the data or whatever. While n is the number that we did, and then the chi-square results is 6.68. Now this is the point takeaways here. The p is 0.351. Now, as we usually do, the p-value alpha is 0.05, which if it's less than that, whatever, that's when we can reject the null hypothesis. Since that's not the case, we will retain the null hypothesis statement, in which we're going to say that there is no relation found or merged that's in here. So even though I have the result Cramer's V on here, which would mean weak if it counted, it doesn't count because there's no relationship between it. In this case, the number of defaults and the number of cars are independent from one another. Next, we'll look at the comfort level of the population compared to the number of defaults. The null hypothesis here is that there is no relationship between the comfort levels of the population and the number of defaults. The alternative hypothesis is that there is a relationship between the number of the comfort level of the population and the number of defaults. As you can see, the results are very similar to what we just did. You see that the degrees of freedom is once again 6. The number counted was like 150. And we got the result 6.68 for the chi-square test. Now, you see, in this case, P was 0.351. I didn't even bother to put the Cramer's test here because this p-value tells you that, well, the null hypothesis are going to be retained because there's no relationship that's emerged between this. So from our data, it looks like the comfort level and the number of defaults are independent from one another using this test. All right, now this is the most interesting one that we did here. This is the third hypothesis test in which we did the number of cars to the comfort levels of the population. In this case, the null hypothesis is that there's no relationship between the number of cars and the comfort level of the population. The alternative hypothesis is that there is a relationship between the number of cars and the comfort level of the population. Now, this one was interesting. I actually see the degrees of freedom was 9 in this case. The total amount we did was the same with 150, but we got a much bigger value for the chi-square test, which is 450, and you see p is 0, but that's perfect for this. And you see, in this case, that means that the null hypotheses were rejected. So we had to do the Kramer V test to follow up as opposed to see how strong this relationship is. In this case, V equal 1, as we said before, that's perfectly symmetric. So this is like a perfect symmetric relationship between each other is beyond strong. So in this case, you see the comfort level of the population and the number of cars are perfectly dependent upon each other. So that's an interesting takeaway from here. All right, go over some results here. So the chi-square test and Cramer's V. The chi-square test determines if there is a significant relationship between two nominal variables. When I say nominal, I think I'm talking about variables like um, gender, race, and things like that. Things you cannot use arithmetic to figure out. Cramer's V is used if a relationship between the values are found. So in other words, the results for Cramer's V would not be used if there's no relationship found here. So Cameron determined how strong the relationship is. So as we saw from the chart earlier, if it's close to 0, that means it may be a weak relationship between these two variables, while something closer to 1, or in this case, close to, if it's past 0.3, there is indication there is a strong relationship between the two nominal variables. So the results for these particular tests that we did, there was no relationship between the number of cars and number of defaults. There was also no relationship between the comfort level and the number of cars. And at the end, there's a strong relationship between number of the cars and the comfort level. In this case, it was a low p-value, and there was a high Cramer's V value. And that's how we're going to conclude here today. For watching. If you have any questions, please just post on my YouTube channel. I hope you enjoyed this presentation and have a wonderful day. Bye for now.